last class, we were working on using Civil 3D to find the volume. And so far, what you have seen a method called volume dashboard, volume dashboard. And in volume dashboard, it's a so simple method where all you need is number one, import the first data set, which for example represent existing ground, build a surface out of these points. And if you need to edit the surface, then do. You repeat the whole process again for the other data set, which represents the design surface. Once you have two surfaces, then all you have to do is simply go to what we call it volume dashboard, okay? And you've seen we've done this and we came up with a very close number to our hand calculations. We simply said last class is that this method is accurate method. So it is accurate method. However, it is not detailed. And what does this mean? It means you don't get any intermediate results. And I think we discussed that if your boss asks you to find the volume and all you have at the moment is just a snapshot of the final number, which is 3,415.83, I can tell you, nobody is going to believe you because people, they want to look at some results to check you and make sure that you got it right. And that's why we said, okay, we have another method. And the other method is called method of cross sections. Method of cross sections. And the method of cross section, it is something that we discuss in our class when we did the calculation manually. And in this method, what you can do is you need to cut sections through your project, find the area of these cross sections between the existing and the design surface, then use all the areas in equation like trapezoidal or Simpson or prismoidal to find the volume. We will do the same thing here. And I think we already started the method in the last class, and the method has some steps. So what are the steps? Number one, you need to do whatever you have done with the volume dashboard method. So basically, what you have to do is try to create two surfaces and edit them if required. On top of that, you have to add extra effort, more steps. And the thing is, this method, the new method or the method of cross-section requires more effort and it has more steps. However, it is more rewarding because simply it will give you all the intermediate steps, as you will see shortly. So on top of creating two surfaces, you need to define an alignment. Define an alignment. And alignment in Civil 3D, typically it is used for road design, pipe design, railway design. However, this is surveying class. So why are we defining an alignment while we're not designing any of those projects? The thing is, in Civil 3D, as I said before, you cannot cut sections without having a reference line. So in this exercise here, the alignment will serve as a reference line where you can later on cut sections with reference to or with respect to this alignment. So if you guys remember in the last class, we have defined our alignment and I chose my alignment to be on the north side, going from the west to the east. Before we continue, I want to remind you that the location of the alignment, the direction of the alignment, it is completely up to you. Only in my demo, I chose my alignment to be on the north side, going from the west to the east. If you choose another location of the alignment, for example, your alignment could be at the center, going from the west to the east, right there, you can do that. The thing is, your choice will dictate all the numbers to follow, and I will point out this shortly. Now, what happens after I decided my alignment is going to be on the north side? I started cutting some sections. So those sections, in order for you to generate a section, you need to create something called sample line. The sample line is exactly what you see on my screen. I have selected one of those sample lines. Sample line simply shows you where is your section and what is the extent of your section with respect to your alignment. For example, the one that I selected right now, it is happening at station 10, so 10 meters from the start, and the extent is nothing on the left and then 40 meter on the right. We already discussed those sample lines, and so far we have total of 5. One sample line at station 0 on the left, one at station 10, and then another one at station 20, and another one at station 30, and finally a fifth one at station 50. So we have total of 5 cross sections or 5 sample line. Remember, every sample line, it's a cross section. Okay, now I need also to remind you that sample lines are dynamic element. It means we can stretch them to wherever you like. So right now they are exactly at the border of my surface at 40 meter. However, I can simply go this way. I can extend them this way. So this is, I can dynamically extend my sample line. And if I have a section here, my section will follow an echo and will also extend. For example, I'll show you. For example, watch me here. I will just generate here my section at station 10. So you guys can see how dynamic things are. So I will go here from menu sections. Then I will print only one section just to see how dynamic works. Okay, so I'll go here and I say create section view, and this menu here or this window here allows you to plot an individual section, only one section at a time. So what you have to do is you need to pick the alignment. So here is my alignment called my volume alignment, sample line group, and then finally if you drop this menu, you can see we have total of 5 sections. Please look up my screen and identify that we have 5 sections at 0, 10, 20, 30, and 40. I will plot the one at 10, so I will choose the one at 10, and then I will just, I'm happy with all other settings. I will go ahead and say create section view. When you do so, you need to pick any point on the screen where the software plots your section. Here we go. So here is my section, okay? So I want to prove for you that the section is dynamic and it's linked to my sample line. So I'm asking you guys, to all of you, please look at this area. So I will draw here a rectangle. I want everyone to focus here and see what happens. So I'm gonna take my sample line and take it from the grid and then put it back to the 40 meter one more time. I want everyone to check the section, focus on the section. As I do so, please watch. Did you see what happened? Can I get some confirmation of somebody who watched what happened already?
Extra portion removed.
Yeah, so the section went from, it was from 0 to 50, then went from to 0 to 40 only. Okay, now let's go to the other side. So I'm gonna zoom in here and I want everyone to focus here, okay? So I will draw for you another rectangle where you need to focus, okay? I'm sorry, I delete something by mistake, so I will just delete this guy only. And then everyone, please focus here. So I will just ask you to focus here. I will take my sample line. I will stretch it back to 30, to 30, okay? So put it here. And now see what happens. My section is only 30 meter wide. So the sample line is dynamically linked to your cross section. So I said something which I would like to emphasize on it, stresses this time. Guys, what you see on my screen, do you see any mistake? Did I do any mistake by making my sample line shorter to 30?
You're missing some of the cross section.
Exactly. So you can see here the software, when I estimate the cross-section area, it will do only between 0 to 30. And it will ignore everything else, which means I have missed 10 meter between 30 to 40. On the plan view, it is basically this area here. Okay? And that's why the rule is the sample line must go minimum to the border of your surface. If it goes beyond the surface, like outside, great, that's a little bit of waste of paper, but it's not a mistake. Okay, now you can see my section went back to 40. Now, what I'm going to do right now, probably this is exactly what we've said last time. I did 10 minutes of kind of review, so get everybody up to speed. And right now, what I will do is I will plot all the sections, not only one. This one here is an individual section. Let's go ahead and plot all of them. How? You go from menu sections, and instead of you creating a section view, you go and say create multiple section views. It means I want to plot all of them in one shot. Let's do it. So if you click on this option here, you get almost the same window. The difference is it doesn't print one section. It prints all the section within the same sample line group. Now, very, very similar, by the way, very similar to the other option. Uh, you can see here, I need to choose my alignment. So I'm trying to create sections for my volume alignment. And if you remember, we looked at something called sample line group. We group those sample lines. And this is very handy if you want to estimate your project in sections. For example, you want to estimate the volume from 0 to 1 kilometer, from 1 kilometer to 2 kilometer, because maybe they are built by different contractors. In our case here, I only have one sample line group. Next is everything else, like to be honest, like all from my experience, everything else should be fine. Like if you are curious, uh, try to read here what are the settings you can change here. For example, station range. So right now it's automatic. It means it will print from 0 to 40. If you want to go from 0 to 30, what you can do is you click on user specified and simply you can change here the end of your station. I would leave it as automatic. Okay. Here it's about section views, like style. If you click on next, what happens here is you go to a different setting. For example, this one here, it's about production. It's about placement. You remember you're plotting so many sections, and the software can plot them for you in a title block. Title block. So right now the title block is a template from Civil 3D. However, if you want to use your own template or your own title block, you can do that here by clicking on this icon here. And then what has to happen is you go next. So this will simply move to the next line here, which is offset range. You can see everything is set automatic. It means let the software decide. Let the software decide in terms of offset, in terms of elevation, and so on and so forth until you get to the end where you can say, please create for me section views, not only one, views. Okay, here we go. So I'm gonna click on any point here on the screen where the software plots for you all the sections. Let's see. So we have section at 0, section at 10, and so on and so forth. Let's look at one section. Can anybody tell me here on this section what this blue line represents? I'm asking you guys.
Our
Okay, go ahead, sorry.
our cut, where we want to bring everything down.
The blue line represents your design surface, which if you remember, it was at 9. How about the black line, this black line here, what does it represent?
Existing ground?
It represents existing ground. Now let me ask you, do you see how wide my section? Can you read from the scale here how wide my section? Like 0, 10, 20, 30, 40. So how wide is my section? Number is there. How wide is my section?
40.
40 meters.
40 meter. And you can see they are happening right of the alignment. You can see right of the alignment. If my sample line went to the left of the alignment, for example, if I go to station 0 and I extend my sample line left of the alignment, so I click here and then I take my sample line and then drag it and put it left of the alignment. Okay, you guys see what happens if I do so? I don't know why it's not doing it. Okay, let's do this one. So if I click on this guy and put it here, do you guys see my 20 section, my 10 section? You can see, look at the numbers. So now I get left of the alignment. I get something left of the alignment. But the thing is, we have no data. So the blue line stops here, and even the black line stops here at 0, because simply my surface ended at the alignment itself on the north side. Okay. Now, let me ask you, where is the area of the cut? Okay, the area of the cut. You can see this is my existing ground, and the blue is my design. So the area of the cut is simply the area in between the black and the blue. And if I need to remind you, the method is based on cutting sections, finding the area of the cross sections, and then finally place all the areas into Simpson or trapezoidal. So what do you think, what should be my next step? Now I have my section. So can you tell me what is the next step? I'm not asking you to show me on the software, rather than tell me verbally, what should be the next step? Now I have my section. So what is my next calculation?
Finding the area of the section.
Yes, sir, that's true. Thank you so much. So really, next step is we will ask the software to find for us the area of those cross sections. And remember, how many we have? We have total of 5. 1, 2, 3, 4, and 5. Let's do that. In order for you to find the cross section area, you go from menu sections. From menu sections, then you go down to compute materials. From menu sections, you go down to compute materials. When you click on this option here, it's simply review with you. Because remember, I want everyone to understand this. In general, a civil 3D drawing may have 20, 30, 40 alignment. So not necessarily the drawing will have only one alignment. In our case here, we have only one alignment. But in general, there could be 100 alignment. And that's why before you start estimating cross-section area, you must choose the alignment. So it gives you this list here. Where you drop it, you will find your alignment. Luckily here, I have only one alignment. Also, remember that for the same alignment, you could have more than one sample line group. Sample line group, huh? So you can see here, I have only one sample line group, which is from 0 to 40. Great, I'm happy with this. Hit OK. Next is you get to this window here, and this window here allows you to estimate the cross-section areas and even the volume. You wanna come here to quantity takeoff criteria. You drop this menu and then choose Earthworks. So the first step is you go to the takeoff criteria and then you choose Earthworks. Number 2 is on the top right here, there are calculation methods. If you drop this menu, probably you have seen 2 methods in my class. Did you guys learn in my class about prismoidal method?
Yes.
Okay, did you also learn in my class about average end area? I know none of you remember. All of you remember too. I know prismoidal and I know trapezoidal. So I already mentioned it sometime in my class that trapezoidal is simply an average end area, because the trapezoidal does nothing more than estimating the end areas and get the average and multiply by the distance. But it does it in a quick basis, huh? So I want you to understand that average end area is equal to trapezoidal, and then prismoidal is another method. And if I ask you right now, which one you think is more accurate, the average end area or trapezoidal or prismoidal? Which one will give us better results?
Prismoidal.
Prismoidal. Thank you so much. That's correct. However, you know what? I know that you may think that I'm doing something wrong, but you know what? only for educational purpose, I will choose average end area, because you will see later on, I will take you through the calculation. And to be honest, it's easier for you to follow me on average end area method. It is a little bit more difficult if I choose this one here. Although I know that the Prismoidal method will give me a better number. Okay, so the only reason I chose average end area, which is trapezoidal, because of the instruction only, for teaching only. Okay, next is down here, the software is waiting for you to define what we call it existing ground surface, and also what we call it datum surface. I would say here is better. Which one should I use? If I drop this menu, you can see in my drawing I have two surfaces. One I called it existing ground, and the other one called the design. So it looks like it's obvious, huh? So existing ground is EX surface, and if you go to the datum, you choose here your design surface. This is very much like the volume dashboard, where you have to choose a base surface and a comparison surface. Same thing here. You have to decide, tell the software which surface, because it will make a difference in terms of cut and fill. Because if you reverse them, what happens is the cut will be fill and the fill will be cut. Okay. Now, by the way, we're done. So all you have to do is hit OK. Please, everyone, as I hit OK, please watch what's going to happen on the cross section. You know what? I will cancel this one. I will zoom in here because I want everyone, when I do it, to look at the cross section. Watch this. I'll do it one more time. So sections, compute materials, alignment is okay, sample line group is okay. Hit OK. Here is my criteria Earthworks. Here is my method average end area. Here is my existing surface. Here is my design surface. Now watch this, please. I want all of you to look here, because there is something is going to happen here in a second. Let's hit OK. Did you guys notice what happens as I hit OK?
It shaded it in.
Shaded, yes, true. Look at this, all the cross sections. Look at all of them. Software went and simply shaded the area in between the design and my existing. This means, hey, Tahir, I'm successful to find the number of, like, the cross-section area. For example, right now, the software knows that this area, let's say, is 100 square meter. It is not really printed now. It is not printed right now, so we cannot see it right now. But internally, the software right now has estimated those cross-section areas. Okay? Now, finally, I'm asking you, if you have all the cross-section areas, for example, you know the area here is 95, and the area here is 100, and the area here is 105, and the area here is 80, and so on. I'm asking you, how can we find the volume? Any tip? This is something, by the way, we have done it before in our class when we did the manual calculation. I know all the cross-section areas, and I know the stations, like where are those sections? Can I find the volume? Any tips?
Yes, by finding the depth of fill.
No, we have already the area, so that the depth of fill was just a step going to find the area. So now we have the areas. So I know that I haven't printed the areas for you, but think about it this way, that the software already found all those shaded areas. I'm asking you, if I know all those shaded areas, how can I find the volume? If you cannot remember, I can go back and I can pull out from my lecture notes how we can find the volume. If you can't, please wait. So I'm going to show you here. Probably it's on my slide right away. Okay, probably it's here. Yeah, it's right here. Do you guys remember when I know the cross-section areas? Watch this. So I know the cross-section area here, and cross-section area there, and cross-section area over there. What did I do to find the volume right here? Simply, I used trapezoidal, which is average end area, or I use prismoidal, or I use Simpson. All those methods are acceptable methods to find the volume. But given that I already have all the areas ready for me, are you guys following?
Yes.
Okay, so the last step is we just have to print them. Watch this. I'm going to go ahead and go to add tables. And from menu sections, I go to add tables at the very bottom. then head right and say total volume. So as I said before, right now the software already found everything, found the cross-section areas and found the volume. The only step is to print them on the screen. So I'm just printing them on the screen right now. How? You go from menu sections, you go down to add tables, and then you hit to total volume. Let's do that. So total volume. Now you can see there is a little bit of setup here before we print our table. You can see there are some stuff like style. Okay, style by now it should be known for you. Style, it means font height, color, all of those things, which you know what, I'm not gonna bother for now. I'm gonna print my table. If I like it, great. If I don't like it, I can simply play with the style. Number two, software is waiting. Remember, how many alignment could be in one drawing? 100, 200, 300. So when you try to plot the volume table, please make sure that you choose the right alignment. And also remember, for the same alignment, we could have more than one sample line group. Okay, watch this. If I drop this menu, you can see I have only one. Next is option which you already have seen it before, split table, split table. You guys know that for every section, there is a line of calculation. For every section, there is a line of calculation. How many sections we have here? We have total of 5. So that's easy, huh? I don't have to even split my section. But I'm asking you, what if you design a road and this road is 10 kilometers, 10 kilometers, and we're cutting a section every 25 meters? You guys know how many sections do I have at the very end? I have a section 10 kilometer, road 10 kilometer, and I'm cutting a section every 25 meters. It means 1 kilometer would have 40 sections. 40 times 10 kilometer, it means you have 400 sections, which means in your table, there will be a 400 line. So your table is going to be very tall. It's not going to fit into any of your drawing. And that's why we can split your table. By the way, this discussion is not new. If you have been attending my class and you follow the discussion, we've done this before. Can anybody remind me, when did we split the table before? Okay, for the sake of time, I'll just help myself. So you guys remember when we build a table for points? Table for points. If you have 4 or 5 points, great. But what if I have 100 points? My table will be super tall and it doesn't fit into my drawing. Okay, in this case, by the way, it doesn't affect me because we have only 5 sections, so that's not really tall. Okay, did you guys remember that I discussed with you sometime in my class about the behavior of my table? It can be static or it can be dynamic. Let me ask you, which one should I choose? Static behavior or dynamic behavior, and why?
Dynamic.
Dynamic behavior. Can you please remind me why it has to be dynamic?
It updates the figure.
Yes, sir. So what happens here, if you create a dynamic table, anytime you do a change, and I will show you the change will happen soon, the table will simply update itself. If you make it static, your table becomes just few text and it doesn't update. So we'll leave it as dynamic. Finally, let's hit OK. And here is my table. All I have to do is just print my table somewhere. For example, I will place my table somewhere here. Okay, so here is my table, and you can see the table is not really easy to read. And in the next 5 minutes or so, I will just show you what is the meaning of every number in the table. Very important, by the way. You must understand the structure of the table and how the calculation in the table goes. Okay. First of all, I want you guys to observe how many lines do we have in the table. Can you observe how many lines do we have in the table? How many rows in the table? How many rows in the table?
5.
5. You can see here, for station 0, we have a row, and it goes all the way to 40. So it means every sample line has a row in the table. Now the next, you can see the first column, it contains the station. So station 0, 10, 20, 30, and 40. And this means those are the sections location. Now the next column is zeros. Why zeros? Why all the numbers here are zeros on the second column? Why all the numbers are zero of the second column?
There's no fill area.
Exactly, there's no fill. Watch the cross section and you will see. Remember, we're going, and for existing ground, we're going to elevation 9, which is below the minimum, which means all my cross sections will be a cut cross section, which means zero fill. Now, the third column, this is the areas that I was talking about. Those shaded area, the software found them already and listed them here. For example, 111, and if you are interested, you can do that yourself. You can check this area, 111. So if we go to station 0, this section here, this area between the existing and the design, the software has estimated to be 111 square meter. Again, if you are curious, you can check it out. You can draw a polygon or polyline around the blue and the black, and you can find the area manually. But you don't have to do that. Just to get some confidence in software, you can do that. So the software found the area of 111. Repeated this thing over and over. So for every section, we know the cross-section area. Now let me ask you, here is the area at station 0, and I will try to draw a rectangle around the number. And here is the area at the station 10. I need some help. Can anybody tell me how can we find the volume, not for the entire project, but just only between 0 and 10, from 0 to 10? We've done this one time in our class. If I give you the area at 0, the area at 10, are you able to find the volume between 0 and 10? Any help? Any simple idea how to do that?
Multiply area by 10.
I'm guessing that you're saying the average area. Okay, I'll just give you the benefits of doubt. I'm thinking that you're asking about the average area. So what we have to do is get the average between the 111 and the 97.5. So you add them and divide by 2. So this will give you the average, and then finally multiply by 10. I need some of you guys to do that, please. Please do that. Get 111 plus 97.5 divided by 2, then multiply by 10. And let me how much, please.
$104.25.
Actually, you missed one. You missed one decimal, because the number is here. So your number should be here. Should be 1042.5. So I think you've done everything right, but you missed one decimal. Can you please do it one more time? 111 plus 97.5 divided by 2, then multiply by 10, not 1, 10.
Yes.
Okay, so you can see here, there is 2 columns in my table, and those columns are simply the volume between one station and the previous station. So you can see here at 10, this number here, which is 1042.5, it is the volume between 0 and 10. Can you please do it one more time? We want to estimate the volume from 10 to 20. Any idea how can we find the volume? Not total volume, just the volume between 10 and 20. How much? It is very simple. You just have to go 97.5 plus 95.75. You divide by 2, so you get an average area, then multiply by the station distance difference, which is 10 meters. I need some confirmation. Are you guys getting 966.25?
Yes, I did.
Yes.
Okay, you know what? I will not really waste your time. Here is the total conclusion, our final conclusion. So you can see here, what you do next is after you find the volume in between individual station, you just have to accumulate. What does it mean, accumulate? It means you build 2 table in your two columns in your table, and those has the accumulation. For example, those numbers are 0. So those we don't have any fill, so that's great. We have 0 fill. How about the cut? Watch this. So what you do is you go from 0, you add 0 to 1000, you add 0 to 1042.5. What you do is you get 1042.5. What's next? You take the 1042.5, you add that to 966.25. Can anybody do the math, please? Add 1042.5 plus 966.25.
2008.75.
Which is here, huh? So this is your number. So this is how the table works, huh? So you keep accumulating, you add the 2008.75 plus 980, like 98.75, you'll get 3007. You add the 3007 to 1011, you'll get 4018.75. So what does it mean? If I ask you right now, what is the total volume to build this 40 meter or to excavate the ground? Can anybody give me the final number? Because we have so many numbers in the table. What is the total volume?
4018.75.
Exactly. So here is your total volume. It's at the very bottom right corner of your table. Now, there is something we want to do, which is check. Remember that we don't know if this number is right or wrong. Do I have a reference? Do I have a reference for this number? Can I compare this number against a good number? Any help? Anybody who followed me from last class that tell me whether we have a base or reference for this number? Do we?
Compare with the first method about volume dash.
Perfect. Watch this. Here is my panorama window. If I'm gonna auto hide, and you can see the two numbers are there. And also my manual calculations. Okay, my manual calculation is here. If you remember, we've done this manually, and here is my volume. Here is my volume. I will minimize, and you can see here is my total volume using three methods. Manual on the PDF file, volume dashboard here on the panorama window, and finally here, the method of cross sections on the table. Do you see, guys? Do you see a problem now? Do you see any problem?
It's not the same.
It's not the same. So the manual almost matches the volume of dashboard. You can see there is a very little difference between the manual and the volume dashboard. However, the method of cross section is off, and off by much. Can anybody give me the percentage? And I don't have to give exact, but roughly we have about 600 cubic meter error. If you divide the 600 by the 3400, what is the percentage? So method cross sections got us 600 cubic meter more. Okay, and we know that how much, sir?
15%.
15%. So which means method of cross section is off by 15%. Now I'm asking you, does this mean that the method of cross section is a bad method, or we have done something wrong?
We could try Prismoidal to calculate volume and see what it comes out as.
I promise you it won't give this big difference. So I mean, I will give you the key, because it needs some experience, and I'm still teaching you, so I'm not expecting you guys to catch this. We have done something wrong, and I will show you where is the mistake. It's not actually a mistake, it is something that we missed. Okay, so I'm going to show you on the plan view, and you kind of confirm for me, please. So on the plan view here, what we did is we cut a section at 20 and section at 30. 20 and 30. And remember, where is my building? Where is my building? It's in between 20 and 30. Let's take a look at the cross section. Let's take a look at the cross section at 20 and 30. So the section at 20 is here. It is a 40 meter wide. 40 meter wide. And the section at 30, it is also 40 meter wide. Mathematically, the software, what it did to get the volume, simply it took the area at 20 plus the area at 30, which is 104, and get the average and then multiplied by 10 meter. Do you think this is right or wrong? I'm asking you. We have two sections.
Wrong.
wrong. Why do you think this is wrong?
Because we have building there.
We have the building, and you can see here the software, the method has no problem. The method is not at fault. We are at fault because simply the method, we are the ones who pick where is my section, and the software will do the calculation on my behalf. So I'm going to show you right now on how to fix this problem. Please watch. And I know some of you will question me, but probably later on you will understand why I'm doing this. In order for you to force the software to exclude the building, you have to add more sections. So those sections at constant, which is 10 meter, like 0, 10, 20, 30, and 40, those are not enough. Look at this, please. The ground kicks in at the building. So the ground goes from 40 meter wide to 20 meter wide at the building. We never accounted for this. So you know what? Just please try to follow me, and I promise you, before the end, you will get what exactly I'm trying to do. So I will come here and I will say, okay, you know what? I need more sections. You guys know how to do sections? You go from menu sections and you say create sample lines. This is how you create a section. You must create a sample line for the section. Let's do it. So create sample line. Now the software is asking you which alignment. I'm going to hit enter. So when I hit enter, the software will open for me a list of all the alignments in this drawing. I will choose my alignment, which is on the north side. I'll hit OK. Now I go here and I make sure it's at station. I'm trying to cut a section at station. So you can see here, I'm ready to cut my section. What is the question? You can read from the command line. Specify the station along baseline. You know what? Just please watch me. I will choose here 20.01. Look at the number, 20, the station is 20.01. It's only 1 centimeter after the ground kicks in. So 20.01. And then I will hit enter. So the next question would be, how much on the left do you want? Any help? How much do I need for this section on the left of the alignment?
0.
0. Thank you so much. Now I'm asking you how much on the, on the left, 0. Sorry. On the right, how much on the right? The 0 was on the left. How much on the right? I know some of you right now are thinking, should I do 20? Should I do 40? Should I do 50? You know what? Please just follow me for now. I know there is a minimum, but I will ask for way more than the minimum. I will ask for 50, and I will tell you why. It's just for education, to show you on the sections. So I will ask for 50 and hit enter. So you can see the software has added one more section. Where the section is, you can see it's here. It is just right at 20.01. So there are two sections are very close to each other. One at 20 and the other one at 20.01. Now, am I done? Anybody who is trying to figure out what I'm trying to do, am I done? Is one extra section is enough, or I have to do more sections? Any thoughts?
More. We need
More.
another.
Can you tell me where exactly, if I zoom in, you tell me exactly where should I do my next section? And remember, the whole thing is about removing the building. The whole idea is we want to exclude the building from the area calculations.
29. 99.
Thank you, sir. Thank you. That's so smart. 29.99, 1 centimeter before the ground kicks back to 40 meter. Okay. How much on the left, sir?
0.
How much on the right? I know that you guys will fight between 20 or 40. You know what? I will just ask for way more than I need. I will do 50 and I will show you what's going on the cross section. Watch this. So right now I have added my section, and you know what? I don't need any more. Those are enough. Watch this. I will hit enter to finish the command. And right now what I will do is I will just plot these sections. I got 2 more sections. I will plot them for you. Here we go. How can I create and plot an individual section? You go from menu sections. You go to section, create section view, because I don't want to plot all of them again. I will just need to plot only few of them. So watch this. If I drop this menu, can you please count for me how many sections do I have right now? How many?
7.
We have 7. We have our original 5 at constant interval of 10 meters, so 0, 10, 20. And here we go. We have our 2 extra section at 20.01 and 29.99. Let's click on 20.01 right away. Let's create our section view. And to make it easy for you, I will put them side by side. I will put 20 plus 20.01 like here, so you can see the two sections are side by side. And remember, there is only 1 centimeter difference in between. Okay, they are 1 centimeter away from each other. And let's do the 30 here. So I'll come here, I will say section, create section view. I'll drop this menu, I'll choose 29.99, create section view. I will place it next to my 30, just next to it, side by side. Okay, now let's do some observation. Let's zoom in here. So those sections are just 1 centimeter apart. Do you see what happens to my area? It went from a big area to a smaller area. If you remember, I asked for 50. Look at my sample line length. I asked for 50. Am I getting anything after 40? You can see this area is empty because both surfaces has finished here. Now watch this. This area between 20 and 40. Do you guys remember what happens here? What did we do for the existing? We have removed the building from the existing surface, and that's why there is no existing ground from 20 to 40, and you can see there is no area calculation. There is no shading here. It means my area, it is going to be only from 0 to 20, which means this area here, does it include the building? I'm asking you, this area here, does it include the building? Yes or no?
No.
No, while at 20 meter, at 20, just only 1 centimeter, a section at 20, we have the full area and the area is big. So again, that was not really the fault of the software. It is our fault. We had to add some extra cross section. By the way, the same token applies here between 29.99 and 30. You can see 29.99, we have no building. And then all of a sudden, after 1 centimeter, we have the entire cross section again. Now, the good news is, watch this. The good news is, watch my table right now. Watch my table. You remember my table was dynamic. My table was dynamic. Do you see how many lines do we have in the table right now? Can you please count for me how many lines in the table right now? We have total of 7. And why we have 7? Because I have added 2 extra sections and I didn't have to go and update my table. My table right now echo. I want you guys to look at the calculation right now, please. So right now the software will not take the 20, take the 20 area at 20 plus the area at 30 and do the average. It doesn't do that. So how does it? What does it do? It simply takes the area at 20 plus the area at 20.01. So it takes these numbers and find the average and multiply it by how much? I'm asking you 95.75 plus 35.01 divided by 2. So we have an average area multiplied by the distance. What is the distance between those two sections? Any help?
1 centimeter.
1 centimeter, which is 0.01. And that's why you get here a very tiny volume, 0.65 meter cube. However, the next calculation will be between 35.01 plus 39.25 divided by 2, multiplied by how much? What is the distance between the two sections? Any help? What is the distance between the two sections?
9 meter and 98.
Thank you, sir. That's correct. And that's where you get this volume here. Now, here is the proof. Now I have my new volume. After I added my two sections, those magic, please watch this. So I'm going to open again the 3 numbers side by side. Do you see what's happening right now? Did you see what happened right now after I added those two magic sections?
It's closer.
Is very close, which means you can see the methods, all of them, they are accurate, all of them, they are correct. However, was my fault as a user to simply not to add enough sections for the software to estimate. Okay, so that's why I want to hear making a kind of closing remark for you. A closing remark. Please pay attention to the following. Now you have seen the methods. Now you have two methods. One method there, which is super simple, and it doesn't give you any details. And it gives you here a number, and we know that this number is a good number, huh? It's an accurate number. Another method, which it's a detailed method because it gives you the following. It gives you the cross sections. It gives you the areas. It gives you all the calculations, correct? But it's tricky because if you miss some sections, then you're screwed. Your numbers will not be right. Now I'm asking you, anybody in the class develop a method? Let's say tomorrow you work for a company and your boss asks you to find the volume. Did you create a strategy from this discussion today? What is the best way to go? Which one you're going to use, or which are you going to do both of them or just one of them? Any help?
The method we just learned, I guess, so that you can show step by step what's happening.
So I'm asking you, what if you do the method of cross sections only and you simply missed the one of the cross sections, the important ones, like I showed you in this demo?
I guess do both so you have something to compare with.
Exactly, sir. That's really my point of discussion today. Please, if you get one job, please do it using both. And then what happens is you have a method that has details which you can submit for your boss, while the other method gives you a comfort because simply it doesn't really work based on sections, which is super simple. But at least if you compare them together, you know that you have done something wrong or you have done it right. Do you guys agree?
Yes.
Okay, so any question before we give you a break? Any question before you guys break?
Can you update that table to reflect a different change or a different calculation for your volumes? Like if we wanted to use Prismoidal, is there a way to just quickly update that?
To be honest, I'm not sure. Like if I go back,
Or just make a new one, I guess, probably is the easiest.
maybe, but I'm not sure. I never done this. But to be honest, here is the point. We know that we should use Prismoidal, but the thing is, if I use Prismoidal, the tricky part is, like this one was easy. I ask you, get your calculator and follow me. So that was only for education. You can follow me exactly what's happening in this table. If you plot the Prismoidal, then you have a problem. Because remember, there is a middle section and you have to multiply like d over 6, which is 10 over 6 divided by a1 plus a2 plus 4 of the area of the middle section. And that's why when I teach, I always use the average in the area because it's easier for my students to follow me on the table. Does it make sense?
That makes sense. Thanks.
Okay, so again, you could, I mean, you can try and let me know, huh? You can simply remove the table or leave the table and go one more time to your section, your material calculation, and change the method and see what happens. Okay? Any other question before we break? So guys, now it is 12:55. We'll take 10 minutes a break. I'll see you here sharp at 1:05. Thank you so much.